Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you the introduction of sampling distribution. And before we get on to that, I would like to talk about the idea of statistics. So when we talk about the study of statistics, it can be divided into two categories. The first one is descriptive statistics, and the second one is inferential statistics. So descriptive statistics is all about describing a data set using graphs, using summary measures such as the mean, the median, standard deviation, and all that. So basically just simple description of the data set. Whereas in the inferential statistics, you are more concerned about drawing conclusions or making inferences based on taking samples from the defined population. And when you talk about taking samples, that is the idea of sampling. And here, let me just walk you through the definitions that you should be familiar with. The first one here is parameter versus statistic. Okay, so what is parameter? Parameter is to describe the numerical quantities of the population. Whereas if you talk about statistic, you are describing the numerical quantities of the sample. For example, if let's say you are able to get all the values from the population and you calculate the mean of it. So the mean of that population is a parameter and is usually denoted by this symbol here, mu. On the other hand, if you calculate the mean from your sample, that means the values here come from just your sample, and the mean of that sample is called statistic. It is usually denoted with this symbol x bar. In a similar manner, if you calculate the standard deviation from the population, then it is a parameter, usually denoted by sigma. And if you calculate the standard deviation from our sample, from the sample itself, this is a statistic, and it is called S. Of course, there are other useful statistics, as long as you obtain them based on your sample. For example, if you calculate the median from the sample, it is called statistic. If you calculate the interquartile range from the sample, then this value here is also a statistic. Now, let me just talk about the idea of making inferences a little bit more. Okay, so let's say that here is your population, and you are interested to study a certain random variable. So x here represents a random variable. It represents the value of the elements in the population. It can be anything really. X can be anything. It could be the blood pressure of the people in the population. It could be the salary of the individuals in this population. It could be the age of the students in this population. It could be anything really. So x here is a random variable. And let's say you are interested to know what is mu. So mu here is the parameter. Okay, so let's say you are able to get all the values here. You are able to get all the individuals, all the elements in the population. You are able to get these values, and you calculate the mean from those values. Therefore, the mean here is called mu, and this is a parameter because you obtain the values, this value here from the population. Okay. But usually in a lot of circumstances, we are unable to study everything or everyone in the population. So what we do is we will take a sample. So we take a sample and we're going to study this sample. We're going to study this random sample. So here there are values inside this sample. Okay, and if you calculate the mean based on these values here, the mean here is going to be called statistic, and it is given this symbol. So here is a statistic. And the result from our random sample here will be used to estimate the value of mu, because mu here is usually unknown. Why is it unknown? Well, because you can't study the whole thing. So if you can't study the whole thing, it is impossible for you to know the value of mu, right? So the mu, the parameter mu here is usually unknown, and therefore the idea of statistical inference is for you to use the result from the sample and use it to estimate this value, which is unknown. Okay, so that's the idea of statistical inference. Now let's recall what you have seen in the previous chapters. Well, we have talked about common distributions of random variables, either discrete or continuous. For example, in chapter 5, we have talked about examples of discrete distributions. For example, binomial. If x is a binomial random variable, then the distribution is described by this equation. Of course, I've told you before that distribution can also be expressed in terms of tables and graphs other than equations. Yeah, so those are the idea of distribution of random variables. How can you describe the distribution? Is by giving it an equation or expressing it in terms of tables or graphs. Other examples of discrete distributions are negative binomial and Poisson distribution, and those you have already seen in chapter 5. Now in chapter 6, for example, we have already looked at the idea of continuous distribution of random variables. So as an example, if x is a continuous uniform random variable, then the distribution is described by this equation. And another way to describe this continuous uniform random variable is by using graph. Okay, so if you use a graph, then you will have a straight line to denote a uniform random variable. Now, what is this chapter all about? Well, this chapter is about the distribution of statistics. Statistics are also random variables because the results vary from one sample to another. Okay, so basically what we're going to do is we are going to see what sort of graph or what sort of shape we can get for the statistics. Like I told you earlier, if x is a continuous uniform random variable, okay, let me just be more specific in this explanation. Well, if x is a continuous uniform random variable, you can study the distribution of it by representing it in a graph. And I've said just now, if this is our random variable x is a continuous uniform random variable, then you will get a graph that looks like this, a straight line, and it is uniform from this interval alpha and beta. Okay, so let's say you are interested to study the distribution of statistics. Let's say the statistic is the sample mean. Therefore, you might be interested to see what kind of graph you will get. So here it's going to be the distribution of x bar. Notice the difference between x and x bar, and you will be seeing a lot of this later on in the next videos. And just for now, I just want to stress the difference between what we have here, x, and what we're going to see later, x bar. So x bar here is representing the sample mean, and when you talk about sample mean is type of statistic. So you want to know what's the distribution of statistic. In other words, you want to know, or you want to understand what kind of graph you can get, what kind of special distribution you can assign to this statistic. Okay. In this chapter, we are just going to focus on studying the distribution of sample mean and the sample variance. Okay, so just two of this. Okay, now let me just reiterate the idea of sampling distribution. In short words, it is about the distribution of statistics. Statistics examples that we're going to do here are x bar and s squared, and we're going to see like how it looks like, what kind of graphs that you can get, what sort of special name you can assign to it. Okay, when I mean special name, for example, does it have a normal distribution, or does it have a chi-square distribution, does it have a t distribution? So that sort of things. Okay, for example, when you have x in a certain setting, you can call it x has a binomial random variable, then this is a special distribution for x, and it can be represented by this equation. And if you, for example, use graphs, you will get certain sorts of graphs associated with this random variable x. Okay, so the same thing about what we are planning to do next. We are going to study what is x bar and what is s squared, and what kind of equation or graph that we can assign to these two statistics here. Okay, now in long words, a sampling distribution shows every possible result a statistic can take in every possible sample from a population, and how often each result happens. And I think the idea of this is better illustrated with a simple example, and that's what I'm going to do. I'm going to consider a visual representation of sampling distribution of the sample mean. Okay, that's what we're going to do right now. Okay, now let's assume that this is my population. Okay, let's assume that this is our population, and let's say we are interested to study a certain random variable, and we're going to call it x. Okay, so let's assume that in this population we only have four elements. Okay, so maybe we have elements, this one here. Okay, just to make it easy for us to calculate and to see the process. Okay, let's say this is the first result here. We have value of 1, this one is value of 2, value of 3, value of 4. So we would like to, for example, if you want to study the mean of the population, well, the mean of a population is going to be equal to mu, and you will know that since we know all the values here, we know that it is just 1 plus 2 plus 3 plus 4 over 4. This is going to be equal to 2.5. So that is the value of mu, that is the value of our parameter. And if you want to like study the distribution of x, now this is easy, and we can represent it using a graph. So we can represent it using a graph. So this is x, and now we are going to study how often each result happens. So the results that we have is 1, 2, 3, and 4. And let's say we consider how many times 1 happens. Let's consider the relative frequency then. okay? Or the probability of that happens is 1/4. So here might be 1/4. So this is the relative frequency. How the probability of that happens is 1/4. The same thing for 2, 1/4. This one is also 1/4. This one is also 1/4. So here is the distribution of x. So here is distribution of x represented using graph. Of course, you can represent this using a table as well. And if you want to represent it using a table, then you can write down x as such. 1, 2, 3, 4, and the probability of it is 1/4, 1/4, 1/4, and 1/4. So that's the idea of distribution. Okay, and this represents the distribution of x. Now let's talk about the distribution of statistics. It says here, when you talk about sampling distribution, you want to find every possible result a statistic can take in every possible sample. Now let's say that we are going to sample, we're going to sample 2 items. We're going to sample n equals 2. We're going to sample 2 items from this population with replacement. So let's say you get 1 the first time, and then you will replace it back into the population. Well, the second time you draw an element, you might get either 1, 2, 3, or 4. So possible samples could be 1 and 2, or 1 and 4, or 3 and 2. But we need to think about a systematic samples. Like, you need to think about all the possible samples, so you need to be systematic about it. Okay, so we can think about it in terms of, well, let me just come up with a table. So let's say that this is the sample of n equals to 2, and then and here is the result of x bar. Okay, we want to find what is the sample mean. Okay, so here is the sampling distribution of the sample mean. This one is the value of mu. And so let's see the result of our sample mean. Well, our sample mean can be different each time you get a different sample. Okay, well, now you can imagine you might get, the first sample that you might get could be 1 and 1, right? It could be 1 and 2, 1 and 3, 1 and 4, because we have 4 elements altogether. The next one that you get is, you might get 2 and 1, 2 and 2, 2 and 3, 2 and 4. You may also get 3 and 1, 3, 2, 3, 3, 3, 4. And finally, you may get 4, 1, 4, 2, 4, 3, 4, 4. So altogether, there are 16 possible different samples. Okay, so 16 possible samples altogether. And based on each sample here, you can obtain the value of sample mean. So here is the value of sample mean, x bar, we call it x bar. You can see for this one here, the value is going to be 1 plus 1 over 2, which is going to be 1. 1 plus 2, 3, this is 1.5. 1 plus 3, 4, this is going to be 2. 5, it's going to be 2.5. 3 over 2 is 1.5. This one is going to be 2. 5 over 2 is 2.5. 6 over 2 is 3. 4 is 2. 5 is 2.5, 6 is 3, 7 is 3.5, 5 is 2.5, 6 is 3, 7 is 3.5, this one is going to be 4. So I hope you can see that the value of x bar here is different from one sample to another, and therefore we say that x bar here is also a random variable because the value here varies according to what sort of sample you can get. And in the sampling distribution, we are interested to study the distribution of x bar. In other words, we are interested to see if I plot all these values in a graph, how does it look like? Okay, so that is the simplest way to represent the distribution of statistics. You can represent it using a table, you can represent it using a graph. And that's what I'm going to do. I'm going to represent the distribution using a graph. So here is how it looks like. And notice that the x-axis here will represent the value of x bar. Okay. Again, there's a difference between x bar and an x. Okay, so that's a difference. X, this one here, when you take all the original values from the population, we're talking about x. Right now, we are talking about x bar. What is x bar? X bar is a sample mean. It is a statistic. Therefore, right now we are interested to study the distribution of statistic. And this is the idea of sampling distribution. Okay. So you can see here we've got values such as 1, 2, 3. The highest value is 4. Yeah. Okay, and here is going to be the relative frequency or the probability of getting all those values. Okay, right now you can see that for 1, it happens only one time out of 16 possible different sample. So here it's going to be 1 over 16. Let's say that this is the point of 1 over 16. So 1 is at this point. Okay. The next highest value is 1.5. So 1.5 happens at this point, at this point. So that is 2 times out of 16. So here is 1.5, 2 times, so maybe 2 over 16 is at this position. Oh no, sorry. Let us make it a bit higher. Okay, so maybe roughly it will be at this position, yes, 2 over 16. And this one here at 4 values of 1.5. Next, you can see 2, 2, 2. 3 out of 16. So here will be at this point maybe. So that is 3 over 16. Okay. Next, 2.5, 2.5, 2.5, 2.5, 2.5. So that is 4 out of 16. So that is at position 2.5. So 4 over 16 may be somewhere here. So right now, okay. And we will continue doing it for other values, such as 3, 3, and 3 happens 3 times. So it will be at this position. And then 2.5. Sorry, 2.5 we are done, 3 we are done. Okay, next is 3.5. 3.5, this one, so 2 times. Okay. And finally, we are left with this value here, 4. 4 happens 1 time. Okay. So this is 1/16. So this is the distribution of statistic, and you can see if you add up all these probabilities here or relative frequency here, it should be equal to 1. That's the characteristics that you have learned in the earlier chapter. And I hope you can see that what we are doing right now is no different than what you have learned in the earlier chapters, except that right now we are interested in studying the distribution of statistic. And again, in this chapter, we're just focusing on the distribution of x bar and s squared. Okay. Well, I think that's all for now. Thank you very much for watching this video, and I will see you in the next one with more examples related to the sampling distribution of the sample mean.